Hello everyone, we have learned 10 most popular data structures, and today we're going to talk about algorithms. With data structures, we know how to store and query data. Now we're going to learn about popular algorithms to efficiently extract useful information from the data that we already have. This tutorial is a part of the data structures and algorithm class. First, we're going to talk about the importance of information in nowadays businesses and daily life. It's the obvious truth that nowadays and certainly into the far future, no business can operate without the help of software. Why is that? It's because that everything we do today is heavily data driven, or in other words, information driven. Without information, businesses or even daily life routine cannot run. And the role of the software is software store a lot of information, processes, and then return the useful information that's gonna help the business to save money, time, or both. Or it can be just simple bookkeeping for your daily operation. Let's take an example of farming. Farming used to happen with a lot of human labor, and there's no need of software back then. And as a consequence, the productivity is pretty low. With the help of software, people can save a lot of time and money in farming. For example, people can use the exact amount of water that the plants need by constant measuring and irrigation. That's gonna save a lot of water. And we can do the same thing with fertilizers, lighting if our farm is indoor, and so on. And all of this useful information and effective action based on the useful information combined help business to save a lot of money, hence increase productivity of farming. Let's have a look at another example. Managing money, formerly called banking. Banking happened before software, so without software we have to do bookkeeping. Every transaction is gonna go to the book. It was very tiresome and slow for inputting a record, retrieving a record, and analyzing records. With the help of software, this operation happens within a blink of an eye, and we almost take it for granted. As everything is so convenient and fast. It used to be very slow and less available. Nowadays, we can have banking in our hand with our mobile devices. So software return useful information that will help business to save money or time or both. There's an important note that we should see here, that these businesses occurred even before software. You can see that farming and banking, they exist for a very long time before software come along. And when software comes along, it usually increases the productivity of these businesses. So increasing productivity is key here, because software alone cannot do anything. It's almost meaningless. You can save any number or text in your computer, but without the meaning that the business give it, those number or text doesn't mean anything. So usually software need to go along with some kind of business to make itself meaningful and impactful. Next, we're gonna talk about the software problem. To boil it down to the core, there's only one software problem. The software stores a lot of raw information that represents something real in life, and the only problem is trying to extract the useful information from existing information that can drive actions that save time, money, or both. And we try to do it efficiently in terms of computer resources, CPU, RAM, and bandwidth. So let's have a look at this example. Let's say we want to go from San Jose to San Francisco, and we're gonna have a lot of options to do so. But ideally, we want a sorted path to go from San Jose to San Francisco, because nobody wants to spend extra time to travel or spend extra money for gas. So the useful information that we have here is the best route that most save traveling time and gas money from San Jose to San Francisco, which is this blue route that we see here on the map, where it's gonna take only 1 hour 4 minutes. And just like the sorted path that the software can give us, optimal and useful information, this is how software helps businesses and daily life, giving the most useful information to save time and money. Next, let's talk about typical classes of the software problem. So we know that there's only one software problem that to find useful information from existing information. And useful is key here. There's a few classes of useful information that we can see repeatedly across different industries and businesses. Here are the top 5 typical classes of useful information that we usually see. Maximization is very much desirable in any businesses or industry that we want to maximize profit or gain or something that is good for us. The same thing with minimization. We always want to minimize loss, spending, or time. These two useful information are very popular. Third, finding all available options with some given restriction, just like a query, to have a little choices on solutions paths, like the one that we can see here in the map. And fourth, finding the most optimal solution with some given restriction, some travel path at given time and cost restriction, that we need to balance out the most optimal solution for both time and cost, or maybe more restrictions. And fifth, finding a truth. For given data, we try to find a truth that's contained in that data. For example, finding a binary tree height of a binary tree, or finding a material volume of a hollow sphere. So these classes of useful information are very popular, and because it's happened all the time across many industry and businesses, people study them, try to find the best algorithm that solve them, and then teach them to the next generation. And that's what we're gonna learn. Next, we answer what is an algorithm, the main topic of today's tutorial, after having the context. So an algorithm, your algorithm, is simply a solution for a software problem that you are asked to solve. That's it, it's that simple. If you write a solution for a problem, that is an algorithm. Next, a popular algorithm that you're gonna learn is a well-defined solution for a particular class of software problem. And most of the time, the problem is gonna fall into these five. So again, it's a well-defined solution for a particular software problem. That means the solution is very well-defined and the problem is also very well-defined. You may ask, why do you have to learn popular algorithms? The answer is because those classes of problems are very popular, and it's most likely that you need to solve them if you work in software industry. There's a note that to understand the algorithm well, you must understand the class of the problem that is solved first. And as a smart and bright student that you are, you might say, I think I can come up with an algorithm myself to solve the problem. Yes, I very much think that you can too. But can you do it within 30 minutes? And will your solution gonna be more efficient than the one that humankind has been perfected in the last 70 years? For example, how you gonna solve the sorted path problem from point A to point B? Like the example traveling from San Jose to San Francisco we saw above. Why are you spending time thinking about this? A person who learned popular algorithm can immediately think about breadth first search to solve this problem efficiently. Next, what can you do after learning a popular algorithm? Well, first, you understand the class of the problem it solves clearly. Second, you can quickly identify if the given problem is solvable with the algorithm that you already learned by examining the problem characteristic to see if it's conform with the class of problem that this algorithm solves. Third, you can quickly explain code and calculate the bigger complexity of the solution. And last but not least, you have collected a new tool in your toolbox, which will help you to solve problems faster and be more confident in facing new problems. Next, I want to quickly talk about the common mistake while talking about an algorithm. So the most common mistake is people don't really understand what class of problem the algorithm solves. Let's take a step back and stress the importance of it. That how humans come up with an algorithm that they decided to teach you. So problem emerges and it repeats itself a lot of the time. And there's a lot of people trying to understand the problem. They seek for a lot of solutions and they choose the best optimal solution to teach. And that is the algorithm that you're gonna learn. As you can see at the very beginning, the problem is very specific, which means that it's very well defined. So understanding the problem clearly must be the first and important part of learning any algorithm. Do not make this mistake. Next, do learning algorithms kill creativity? It's an easy no answer because you're gonna see a lot of problems, and most of the time you want to adapt those non-conform problems into the problem that can be solved with the algorithm that you already learned, and that requires some creativity. Also, many problems require a combination of a few algorithms to solve, so you might need to mix them up cleverly to achieve your goal. And you can think of these algorithms that you learn here are just basic Lego pieces. And what you can build out with these pieces is an endless possibility. That is all for today's tutorial. Thank you for watching, and I will see you in the next video.